So the scope of the variable is a part of the program in which the variable can be accessed. It cannot be used before it's defined, and it cannot be used after it has fallen out of scope. So what does that mean? Say I have a program and it's got a main, and it looks like that, and I define a variable here. I can't use that variable on any lines above its definition. That variable hasn't been created until here, so I can't put anything there. This would give me an error if I said a is equal to 10 there. Now that sort of makes sense. I mean, that's pretty obvious. You can't use it until after you've defined it. Swap those lines and everything works good. Where it gets a little bit more subtle is when you have other brackets. Like if you have this statement. If b is equal to 10, say we defined b somewhere. Well, let's just do this. If a is equal to 0, in which case we should have given a the value of 0 if we were going to make this actually a valid program. Then we create a variable called int b, and we assign b the value of 2. The scope of this variable is only within the brackets here. This is the only place where that variable is valid. This a is only valid from here to here. Now that may sound silly. Well, isn't that the entire program? No, it's not. You can define functions down here below this last brace, or above this first brace, or in other files. And this a is not available in other files, or above this brace, or below this brace. This b is only available from here to here. So if I come down here and I do cout, arrow, arrow, b, right here, that's going to give me an error message. I'd have to cross that out, with that there. This won't work because b is only defined here. It's only valid from here to here. That's the scope of that variable. Some people call it the lifetime of that variable. Scope may be a better term. I don't know. This variable has a scope from here to here. So the scope of the variable is after it is defined all the way up to the closing brace that matches its level. This one's braces are here. This one's braces are here. So this guy's scope is from here to the last brace of its level. And this guy's scope is from here to this level. Now it doesn't work the other way. I mean, it's totally good to try to use a inside these braces. This is totally fine. I could do this. B is equal to a plus 2. You might say, well, why is that valid? A isn't defined within those braces. Well, yeah, it's defined before that brace. So A is available for use anywhere after it is defined up into the closing brace that's in its level, including there. So A does work there, but B does not work here. This would be an error. We cannot do this. Error because he's out of scope. So a variable is only in scope after it is defined and before the closing brace for its level. Hope that makes sense. Variable out of scope. We cannot print out cout here because cout has not been defined yet. Excuse me, value has not been defined yet. We'd have to define value before we could display it to the screen. Arithmetic operators. The arithmetic operators are things like the plus sign, the minus, the times, the slash, and here's an unexpected one, %. These all mean things that you recognize: addition, subtraction, multiplication, division, and one you may not recognize, which is modulus. That's another word for remainder. So the way these work, pretty subtle, pretty obvious. What's 1 plus 2? Well, that's 3. What's 2 times 3? That's 6. What's 6 divided by 2? We're all good at basic math. What have I left off? Subtraction. 4 minus 3, that's 1. Now, we did the divide by. Modulus is similar to divide by because it means remainder. 6 modulus 2 equals 0. And the reason for that is how many times does 2 go into 6? It goes in 3 times with a remainder of 0 because it fits cleanly into it. There's no fractional component. So 6 divided by 2 is equal to 3 with a remainder of 0. That's what modulus means. Modulus means remainder of. So 7 modulus 2, well, how many times does 2 go into 7? Same number of times, 3. But how many are left over afterwards? 1? Are we all good on this? Some of y'all aren't looking. Hope you're picking it up. So that's a remainder of 1. What is 10 modulus 4? 2, exactly. What is 10 modulus 5? 0. What is 9 modulus 10? That one looks a little weird, but how many times does 10 go into 9? None, with a remainder of 9. Because you can't divide it. It's like, 9 divided by 10 is equal to 0 if you had to round it down. And then so 9 minus 0 times 10 gives you the remainder. So it has a remainder of 9. So any number, modulus another number, if the first number is smaller, is equal to that number. 3 modulus 4 is a remainder of 3. Because 4 goes into 3 0 times, and you have 3 left over. We all good on that? Cool. Okay, so that's modulus. Then we have to talk about order of precedence, precedence of operators. The term operator just means the symbol, the math symbol. As you may remember from elementary or junior high or whatever, some symbols have higher precedence than others. If you type into a calculator 2 plus 3 and hit enter, and then you type times 4 and hit enter, it's going to display something. What's 2 plus 3? That's 5. Times 4 is 20. You'll see 20. However, on your little TI-30 or whatever, if you type in 2 plus 3, don't hit enter, and then type times 4, it's going to give you a different answer actually. And if any of y'all have a calculator in your hand, you can prove it. What happens is that multiplication happens before addition. So, the 3 times 4, what does that equal? 12 plus 2 is 14. So instead of saying 20, your calculator would display 12. 14. So there's a rule of thumb that people made up, or a little mnemonic, something to remember by, which is parentheses, that's the P, parentheses, exponents, well there is no exponent operator in C++, so we're going to leave that one off. And then multiplication, division, which is asterisk and slash, and addition and subtraction, which is plus and minus. So these are the highest priority. Anytime you have an equation, whatever is inside the parentheses gets done first. And then you get the multiplication and the division. Then you get the addition and the subtraction. So what is 10 plus 2 times 20? What gets done first?
Multiplication.
Yeah, multiplication. Okay, I'm hearing 2 voices. I want to hear like 3 voices next time. Okay, so 2 times 20 is 40, plus 10 is 50. How would you get the 2 plus 10 to happen first?
Parentheses.
Yeah, you'd use parentheses. 10 plus 2 times 20, which is 10 plus 2 is 12 times 20 is whatever, 240. Sorry, I should have made these smaller numbers. Okay. So remember PEMDAS. That's how you remember the precedence of the operators. Parentheses happen first, then multiplication and division, and then addition and subtraction. If they're equal, like multiplication and division, or addition and subtraction, they just happen left to right. It doesn't really matter. Because if you have 2 plus 4 plus 2 minus 1 plus 3 minus 2, it doesn't matter which of these you do first. You'll get the same answer. We can kind of prove it if we wanted to. 3 minus 2 is 1, minus another 1 is 0, plus a 2 is 1, 2, plus another 4 is 6. Okay, so going that way to that way, we got 6. 4 plus 2 is 6, minus 1 is 5, plus 3 is 8, minus 2 is back to 6. So, whichever way we solved it worked. And the same is true for multiplication and division. So if they're of the same priority, you just solve it left to right. This is pretty self-explanatory. 7 plus 3, 10. 7 minus 3, 4. 7 times 3, 21. 7 divided by 3, well, these are integers, so it's going to round down. How do you know they're integers? There's no decimal point. If you divide an integer by an integer, you get a number with no decimal point, and it rounds down. So 6 divided by 3 is 2. 7 divided by 3 is also 2, because it rounds down. 8 divided by 3 is also 2. And then 9 divided by 3 is 3. So that's worth taking note of. Integer division rounds down. So 6 divided by 2, both 6 and 2 are ints. How do we know that they are ints? Yeah, no decimal. Because no decimal points. Otherwise they would be floats. 6 divided by 2 is 3, with a remainder of 0. So if we were using modulus rather than divide by, it would be 0. I guess we could put that comment down here. 6 modulus 2 equals 0. And then 7 divided by, no, I was doing 3. That's more interesting. Okay, so 6 divided by 3 is 2, with a modulus of 0. 7 divided by 3 is still 2. Come on. But what's the remainder now? If you divide 7 by 3, it fits in 2 times, but you get a remainder of, 1. I know somebody isn't getting it, because I always have 2 people who aren't getting this particular thing, modulus. It sticks in their brain and they don't ask. So hopefully somebody will ask later. 8 divided by 3 is still 2. But it's a different remainder. What's its remainder? Yeah, it's got a remainder of 2. And then 9 integer divided by 3 is 3. Because 9 divided by 3 is 3. With no remainder. So 9 modulus 3 is equal to 0. So what could you use division and modulus for? Say you have 589 pennies, and you want to figure out how many dollars and cents that is. Dollars in pennies. So 589 divided by 100, doing integer math, so it rounds down, is how many? How many dollars do we have out of here? We have 5. And then 589 modulus 100. Well, when we divided 589 by 100 and we cashed in $5, what was the remainder? Yeah, we have 89 pennies left. So, dollars is equal to 589 divided by 100. Pennies is equal to 589. You could do the same thing with miles and feet. Say something is 10,000 feet. And you wanted to calculate how many miles in feet that was. Well, kind of an obscure number, but 1 mile equals 5,280 feet, for reasons lost into antiquity to me. I'm sure it's in Wikipedia. So the number of miles would equal the number of feet divided by 5280. Let's make this look all official and stuff with int. So in this case, what is 10,000 divided by 5280 in integers, rounded down? I know those are large numbers, but we can kind of guess. Yeah, it's 1. So it's 1 mile. And then we would say feet is equal to feet divided by 5280. Now I really can't do that.
4720.
Thanks. Did you use a calculator on that, or you do that in your head? I'm impressed. Okay. Cool deal. So you can use modulus in order to do that kind of calculation. Now, if you have a distance in one thing and you want to convert it to more friendly units, like pounds and ounces, you know, or gallons and ounces. All right, we've already done binary. So division does integer division, meaning it rounds down, if both operands are integers. Remember the word operand. The operand are the numbers that the operator works on. The division or the addition or the multiplication or whatever is the operator, and the numbers to either side are the operands. So 13 is the operator, 13 is the operand, 5 is the operand, and divide by is the operator. Why is it rounding down? Because both operands are integers. If either operand is a floating point, the result is floating point. So the operator is the math symbol, you know, one of these, multiplication, division, addition or subtraction, and the operands are the values that the operator works on. So if you do 10 plus 20, what's the operator? Yep. What the heck did I just type? Okay. And what are the operands? The other two things. 10 and 20. Yeah. Is this going to be integer math or floating point math? Yeah, that's integer math, so we're going to get an answer of 30. Although really subtraction is and division is the one where the behavior modifies dramatically. Pardon me?
Is that in relation to like when you're putting int equals?
Exactly. If you put int is equal to 3, that makes it that variable an integer.
Okay, when you put int though, you're assigning it a value, right? Like
If you put an equal sign, yeah.
Okay.
Yeah.
So if I said like int age or something, int equals age, I don't have to put it.
Yeah, you do
Okay,
int
associated
age. The age doesn't have a value yet, but then if we turn around and do that,
Okay.
oops, then int will still be an age, no matter what they typed. Excuse me, age will still be an int, no matter what they type. So if we do this, age divided by 2, well, they're still both integers. So the answer is going to be rounded down, and a rounded down integer.
So the difference between that and float is float just has decimals.
Right.
Okay.
So I revised this one a little bit. Whoops. The Let's revise this still further. Let's do this. Float x is equal to 25. We have declared the variable x and we have initialized it to 25. Float y is equal to 10. Except, let's make these ints first. These are ints first. And then we're going to see out x divided by y. So our operator is plus sign. Well, no, it's not. It's divided by. Being sloppy. And our operands are 25 and 10. So since both of these are ints, both x and y are ints, both x and y are ints, so division will do integer math. So the answer is 2 because integer math rounds down. 25 divided by 10 is 2 in integer math. Now if we did the same thing but we declared these as floats, float x is equal to 25, float y is equal to 10, and let's make these different variables, a and b. And then we see out a divided by b. Well, our operator is still divided by, our operand is still a and b. Well, our operands are a and b. Both a and b are what? They're not ints, so they are float. They're floating point. So divide will do floating point math, which does not round down. So 25 divided by 10 doing real math, doing floating point math, is 2.5. Here's our example, 13 divided by 5. These are ints, both ints, so it rounds it down. 91 divided by 7. These are both ints, so it rounds it down. 13 divided by 5.0, well, one of them is not an int, one's a float, so the answer is going to be a float, so it doesn't round it down. You know, and I'm just trusting these numbers. I haven't divided 13 by 5 or 91 by 7 to make sure it works. But in this case, it looks like it gives you the same answer, 13 and 13.0. Well, yeah, it's the same value mostly, but they are different data types, so they're not exactly the same thing. The computer stores them completely differently inside. Modulus requires integers for both numbers. Some languages this is not true, which is a wild thought. If you did 13 modulus 2.5, you could do it. I can't figure out in my head what it would equal, but you could. However, in C, C++, they both have to be integers. So if you tried to use 2.5 as one of the operands, since that's a float, that generated an error. You raising your hand or? Okay. All right, comments. We know what a comment is. A comment is the // There are two kinds. Single line comments, just //. A multi-line comment starts with a / and ends in an */ and it can span multiple lines. This is a multi-line comment. You can comment out 200 lines, 2,000 lines if you want to. You just put one of those at the top and another one of those at the bottom. However, there's a warning there. Let's actually need to open up Visual Studio in order to demonstrate this. I'll open a project I've already written. Alrighty. So let's say I want to comment out some of this stuff. I decide I don't want to display this message, enter your name. That is kind of moronic. I really would want to. And let's say that I use that to start the comments, and then I use that to stop the comments. That is valid. I've used that and that to make a multi-line comment. Now let's say later on I want to comment out a whole bunch of code. So I come up here and I put that up at the top, and I come and I put this down at the bottom. That's not going to work. And the reason why is you can't nest comments. What's happening is the code commenting starts at the first star slash and it ends at the first slash star, which is right here. The first slash star is here. It doesn't matter that there were extra star slashes between those. The comment block starts here and ends at the first star slash. So now this code is not commented out, even though we meant it to be. So multi-line comments, you can't nest them. If you're going to comment out code, it's better to use slash slash on every line. So if I wanted to comment this stuff out, that would be a better way to do it. And I believe that there's a fancy keystroke for commenting out a bunch of lines at the same time if you want. You can highlight several of them, and then you can go up to Edit, Advanced. I guess there's not. Different editors do different things. Here we go, comment selection. And that puts slashes in front of everything. And then if you want to uncomment that section later, you come back out here and you do the opposite. Edit, Advanced, Uncomment. There's also increase indent and decrease indent. Now that I have those two lines highlighted, I can do increase indent, and that tabs it over. Or I can just highlight those two lines and then hit the tab key. What if I wanted to go back the other way? I could either come up here and do Edit, Advanced, Decrease. And of course this is, Visual Studio specific, so the Mac users and the Linux users will have slightly different, but most programming environments do this kind of thing. Decrease does that, or I just highlight those two lines, hit Shift Tab, and it starts going back like that. One more useful keystroke is that if you're sitting on top of a brace and you want to find where its partner is, you hit Control, close brace, and it bops down to the other end. See, there's the brace for that one. Now let's say that I had an if statement in the middle here for some reason. If, I don't know, if weight is greater than 2, for whatever reason. And so we have a code block here. By the way, notice the scope. Pounds per year only works inside these braces. If I tried to print out pounds per year down here, that wouldn't work. Okay, so if I'm sitting on this one and I hit Control close brace, which is above the enter key, it blips down to there. It jumped from there to there. If I do the opposite, if I move it to that brace and hit Control close brace, it bops back up to here. And yeah, that's not a big deal. We were only separated by 2 lines of code. However, if you're working in a module that's several hundred lines of code long, and there's a lot of code between braces, it's a really fast way to go. I move down here, I hit Control close brace, and it jumps up to the opening brace. Just useful tricks. Used to be that people, had almost religious fervor about their favorite editor. There'd be an editor called Brief, and ooh, I like Brief, and I won't use any other editor. Or I like VI, and I won't use any other editor. However, nowadays people tend to use the editors that comes with the IDE, the Integrated Development Environment. So if they're a Windows developer, they probably use Visual Studio, and they probably use this editor. If they're a Mac user, they use whatever one comes in CodeBench. Okay. So single line comments only comment out one line, like that. What are they used for? They're used for humans to look at. Programs ignore comments. It doesn't matter whether this says calculate rectangle area or I hate C++. It doesn't hurt the compiler's feelings. It just completely ignores it. But it's there for us. Professional programmers do put comments in their code, so that's one sign that a code was written by a professional, is if it's commented nicely. And what I mean by that is you don't have to comment every single line like he's doing here. If you have a 200-line comment and every single line of code is commented, it's way overkill. But if you have a formula in the middle of code, or you could write a block of code and you want to put a comment up at the top that describes what that does, that's very useful. So anything that's confusing in your program, you should comment it. You should also go and put your name and the date up at the top of the program. Named constants. A named constant is a number that's not supposed to change. Now, I already showed y'all using pound define in order to create a constant, but that's not really a constant, it's a macro. A constant is a variable that's declared as any other variable is, with a data type like int, but it's got the word const in front of it. The reason it's got the word const in front of it is so that if another programmer tries to change the value of it later down in the code, it'll generate an error. So if I come in here and I decide that we have some special conversion factor, float, I'm going to call this conversion, and it's equal to 2.2, and my comment is there are 2.2 pounds per kilogram, and somebody down here decides that, oh, I can use that variable for whatever I want, so I'm going to set conversion equal to 4 for whatever reason. That might break your code. Maybe you were depending upon it being 2.2. Maybe you only wanted it to be used for converting pounds to kilograms. But this works. This would compile. The reason it compiles is because this conversion variable is not defined as a constant. So if I did this, if I build it, it's going to work fine. Even though that could be a serious error. Maybe later on when I'm trying to, display somebody's weight and I ask them if they want to display it in kilograms and I try to divide it by that conversion factor, another programmer or myself forgetting has monkeyed with that value, so it's no longer accurate and we would get wrong output. But if I come up here and I make that a constant, I put the word const in front of it, then when I try to redo it down here, that's an error, so it's underlining it. It won't even compile. If I do rebuild solution, it's going to pop up as in the error list. Right? Yeah, there it is. Now what you also could have done is a pound define. I could go up here and do pound define my conversion as 2.2. And then when I wanted to use it later, if I tried to change it like that, that would certainly give me an error. So there are two ways of defining constants. Is there a reason to do one more than the other? Doing it this way with the const keyword is more how other languages besides C++ does it. Not every language has a preprocessor. Not every language. In fact, very few languages do. So not very many languages will support doing something like that. But almost every language will support doing something like, where did that const go? That. So that might be one reason. Note that when you go on and you take my Java course in the fall, hint, hint, that the keyword in Java to define a constant is not const, it's final. Hey, look, final does something in C too, but it means something completely different. I don't know what that means. Okay. So that's what a constant is. It's a value that can't change. Why would you want a variable if it can't change? Isn't that the idea of a variable, is it can vary? Well, no, not all the time. You set this variable once and it's supposed to stay the same. They show a tax rate, for example, a tax rate being constant. Why would you use a variable like that when you could just divide 2.2 when you want to? Like after we enter somebody's weight and we wanted to convert it to kilograms, we could do float kilograms is equal to weight divided by 2.2. We could do that rather than doing weight divided by conversion. Both of these are accurate. kg is equal to weight divided by conversion or weight divided by 2.2. Both of those are totally accurate. However, suppose you pick some value that later needs to be changed. Now what if that isn't the exact ratio to convert pounds and kilograms? I don't really think it is. I think that it goes out to several more decimal places. Let's do 1 kilogram in pounds. I love Google because you can type conversions in and it'll display the answer. Okay, that's what a kilogram is really equal to. And so if you'd written software and you typed in 2.2 as a literal all throughout your program, then later on when you wanted to make it more exact, you'd have to go and change it everywhere. However, if you just define a constant and use it once, all you have to do is change it in one place. You change it in one place and it's fixed for the entire program. So this is an example of what's known as a magic number. A magic number is one that you will use over and over and over. And so you probably want to define it as a variable so that if you have to change it later, you can't. Tax rates are good magic numbers, you know. Conversion ratios are good magic numbers. If you're writing some program and you're writing a game and you decide that you're going to limit the distance of your character so that nobody can see anything that's more than 100 feet away, you might code the maximum feet that you can see equal to 100. And then later you realize that people with better video cards will be able to see farther away. And if you've hard-coded the number 100 all throughout your program, you're going to have to do a search and replace and find, in 100 different files that you've written, all the instances of the word 100 and change it to 200 or whatever you want to do. Whereas if it was defined as a constant or as a pound sign defined, then it's easy to fix. It's easy to fix. Constants are often named in uppercase letters. The trend nowadays is to make your variable names in lowercase letters and your constants in uppercase letters. Also, pound defines are usually uppercase letters. Same idea. It makes it real easy when I'm scrolling up and down the code. If I see something in all caps, I know that it's a constant. Now, I didn't do that. I'm going to go and delete this constant up here, this macro. I'm going to come down here and make this one all caps, but I'm going to give it a better name than just conversion. I'm going to call it metric kilogram conversion. There, that's pretty specific. Now down here, when I actually want to use it, I would do that. That makes it real easy to see what's going on. That's a lot better than just weight divided by 2.2. That's kind of like, what? What are you doing? If this variable has a good name, then you go, oh, I see, we're converting to kilograms. But what if it had a more vague name, like that? You wouldn't know why we were dividing by 2.2. You would know, you wrote it, but when you came back to it a year later, you might not remember. And then when you hand it to somebody else, they would not know why you were dividing by 2.2, unless they happen to recognize what that was. However, if you do it like that way and you give your constant a good name, it's real obvious. Oh, we're turning it into metric. What's the other thing you could do? You could convert pounds to kilograms. A comment is also good. It's a good way of indicating the same thing. If you have a choice between making a good variable name or putting a comment, it's probably a better idea to put a good variable name, because this may be used in a whole bunch of different places. If it is used in a whole bunch of different places, you wouldn't want to have to put a comment every single place it was used. Okay. So the scope of the variable is the lifetime of a variable, the area in the program where it can be accessed. If you define your variables up at the top of your program, they're known as global variables. I could go up here and define a variable, way up at the top of the program, maybe right underneath the using namespace. And I could say, okay, I want a variable called max age. And I'm going to set max age to 120 because I don't think anybody ever lives larger than that. This is now a global variable, meaning it can be used anywhere inside this file. This is what's known as a local variable. It's local to a specific function. Does that make sense? It's defined within a function, it's defined within a pair of braces, so it's local. This is defined outside of all the braces, so it's called global. Nothing wrong with defining global variables, but unless you have a real good reason for defining it as a global variable, don't do it. The reason is it makes the program harder to modify, especially when you're trying to make a program that takes more than one CPP file. You know, your average application, you know, your average complicated application will have a whole bunch of CPP files in it, not just one. And if you have global variables littered all throughout it, it can be harder to figure out where things are defined. So local variables are the way to go. And as the program gets more complicated, you will be using something called classes. And if you're using classes, you don't use global variables at all. Classes we haven't talked about. That's a more advanced topic. Here's their definition of constants. A constant named pi, 3.14159. Now really, pi is defined in some math library inside C++, so you shouldn't have to define it. However, we don't know what how to pull it in yet, so that's a perfectly good way of doing it. And then for some reason he decides that diameter is also a constant. I wouldn't define diameter as a constant. I'd let the user type it in. But whatever. And then circumference is not a constant because it's being calculated. The value of circumference is calculated based on pi and diameter. And he uses this formula. Circumference is equal to pi times diameter, and then he displays it. All right, we're at the end of the slides. Programming style. Programming style is kind of like the way you write. You know, different people would write things in different ways. Hemingway writes different than, you know, J.K. Rowling, who wrote, you know, all the Harry Potter books. So the programming style between programmers is pretty noticeable. If you sit down and you look at one programmer long enough, and then you sit down and you look at another programmer, it'll just look different. And the reason is that one of the things they do differently is they visualize the code differently, meaning they put spaces and tabs and blank lines and braces in different places. For example, some people do it like this. They don't put the brace there. This is known as a block style of braces. Instead, they put the brace there. And they put that brace there. And then later on in our if statement, they put that brace there. That's a really common way of doing it. However, I think it's clearer to look at if the braces are lined up like that, in block style. This has a different name, and I forget what that name is. It's also called the K&R style, because the guys who invented Unix and the C programming language were named Kernighan and Ritchie, and that's what they preferred. This does have one advantage, which is that when I'm trying to get as much code on the screen as possible, then I'm saving a line each time I do that. This also has another advantage. Once people get used to the idea that they have to put semicolons, they always want to put one after the if statement. That does not work. That breaks the code. But if you had a brace right there, would you put a semicolon there? No, that makes it real obvious that you're not supposed to put a semicolon. It kind of looks like a sad face emoticon with a mustache or something. I don't know, he's winking at us. So please remember, and I know somebody will forget, and I'll have to help you when I'm wandering around the class, no semicolons after if statements. Also, no semicolons in while loops. So if we did something like this, while wait is greater than 2. Not that we've used while loops much in here, but still, that breaks it. The reason why it breaks it is because the language treats it like this. If you see wait greater than 2 and the semicolon is there, here's how it interprets it. It puts those there in its little brain, and it removes these, and that's what the program looks like. So this code executes regardless of the if statement, if you put a semicolon there. That's how it treats it. So no semicolons after if statements. That's part of programming style, is how you tab things and where you put your braces, where you put your blank lines. Do you have to have all these blank lines here that I put? No, not necessarily. You could remove all the blank lines from your program, and it would work just as well. You can even put in multiple lines on one line of code. Everywhere you have a semicolon, you could put another line of code. Now don't turn in a program that looks like this. Don't do that. Some of y'all aren't looking. But I know that is going to be okay. because nobody's going to do that. But that's valid programming. Putting all these statements on one line. Now you wouldn't do that, but you might be tempted to put 2 or 3 statements on a single line. Not like that. That's a bit ridiculous. But maybe if you're defining variables and then initializing them, int x, y, z, then you might want to put x is equal to 1, y is equal to 2, z is equal to 3. That's totally valid programming. It's just harder to read. And realistically, you would probably, really do this. X is equal to 1, y is equal to 2, z is equal to 3. So the programming style I follow is usually one thing per line, 1 semicolon per line. If you wind up typing in something that's more than 1 semicolon per line, there really ought to be a good reason for it. So I would either define it like this, or I would put those numeric definitions right up here. I would say int x is equal to 1, int y, or y is equal to 2, and z is equal to 3. Like that. Because the program's not going to run faster just because you put a whole bunch of stuff on one line. The machine language code that it generates is exactly the same. And the only advantage is when you're trying to fit the maximum amount of stuff onto one screen, like I do when I'm up here, I might do stupid things in order to try to save space so I can get more code on the screen at the same time. And the reason I do that is so that I don't have to scroll up and down, and when you're looking at what I'm doing, you can see all the code at one time. However, y'all don't have to keep it all on one screen. You're not broadcasting it on a projector like I am. So I may do something stupid and put more than one line, but most likely not. That I consider that bad programming style personally. All right, so is there anything else to say about that? Your programming style does not affect the syntax of the program. It just affects the readability of the source code. And you're trying to write code that is readable. One way that you can make your code very hard to read is if your tabs get out of whack. You're cutting and you're pasting and, whatever. The program works just as well if it's like that. We didn't change the program. If I compiled it, it would still work. However, it looks like garbage, especially to somebody who's done some more programming. It's visually hard to interpret what's going on. It's hard to know, what level this code is. Indentation level actually gives you some important information about the program, because each time you have an if statement or a while, you indent the code inside it. So if you see something that's indented like 8 or 9 lines over, it gives you a feel for the program and the way it's structured. Whereas if it's all, higgledy-piggledy or some cute phrase like that, if it's all messed up, it's hard to see. Now then, is there a way to fix it? You've been copying and pasting code between projects and the tabs have gotten all out of whack. You can try this, and it doesn't always work, and I don't know why. Highlight everything and go up to Edit, Advanced, Format, and see if it fixes it. And it did fix it. That's cool. In some editors, it moves all your braces around when you do that. It moves it to whatever brace style it's trying to enforce. However, this one even maintained our brace style. It put a brace here next to main on the same line, but on here, it did a different line. All right, guys, we've been here an hour. Let's take a break, come back in about 5 minutes, come back at about 8:20. And then we'll do some programming. Nobody got up. One person got up. I'm going to lock the door. Nobody gets out after. No, I'm kidding. Oh, absolutely. That looks legit. That's good. Good job. So if you think about ways in which the program could be improved so that the user can't enter stupid data. Now if you're working at a company, you know, and you can be sure that the people have good training, you don't have to do quite as good of error checking. But like what if a user types in a negative weight or a negative age or something like that, then the calculation is going to be totally wrong. And you might want to loop and force them to enter a good value. Or if it's a form, you know, you'd highlight that line. You've seen that kind of stuff on a form. But we're not going to do a lot of that kind of error correction, but we'll do a little. All right, guys, we're going to work on programs that use the if statement. I think we've already used the if statement a little bit, maybe not too much. And if you're a programmer already, you've used them a lot and you already know. This could be pretty self-evident. There is an in-class assignment, but first let's do something else. Let's just do a silly little grade program. So open up a new project, file, new project. Call it grades, or whatever you want to call it. Needs to be a empty project, Visual C++ empty. Then I'm going to right click on the source files and add a new item. I'm just going to put my initials in front of the file name, JGT source. Or I could call it JGT grades, whatever. And I need that boilerplate code, or I just have to type it all in again. # IO stream. Be a good idea to be able to also type this in by memory. Include string using namespace std int main and then some braces and return 0. There's our boilerplate. Okay, so what this program is going to do, I'll put my name up here, the date, and what it does, calculates a letter grade based on a score. And then I'll add the comment, typical grade, pattern, 90 equals A, 80 equals B, and so on, etc. All right, now I've documented it. So the first thing we want to do is tell the user what they're doing and ask them for the grade. So let's think about it. What are the two things that we're going to have to keep track of? One is we need a score variable, and the other is we need to output the grade. So why don't we create two variables? Score, and let's make it a float so that it can be a fractional value, 90.1 or whatever. Float, and let's call this one score. I'm just assigning it a value of 0, score without an S, sorry. And then a string called grade, which I'll just make an empty string or a space or something like that. And we will give that a better value based on a calculation.
What's special about string again?
String contains letters rather than numbers. Right, so when we're done it's going to say A or B or C or whatever. And I could do that with nothing between it, but then it kind of looks a little bit weird, so I put a space there. Okay, so let's tell the user what to do. Enter the student's score, /n. And then let's let them enter that score into the score variable using CIN. Now I feel like making a next thing where we calculate the letter based on a score a function, meaning it'd be in a different part of the code. However, we haven't talked about functions enough, so I'm going to leave it right here. So it's just going to look like this. If score is greater than or equal to 90, and I feel like telling you to always put braces like this, but if I do the braces, the code is going to get really large. So I think I'm going to not abide by my normal style, and I'm going to put that. As a matter of fact, I'm going to delete the braces. It's just going to look like this. If the score is greater than or equal to 90, the grade is an A. Else, if the score is greater than or equal to 80, the grade is equal to a B. Else, if the score is greater than or equal to 70, grade is equal to a C. And we only have two more, D's and F's. How come there's no score E? If score is greater than or equal to 60, grade is equal to E. Else, grade is equal to F. Now that we've calculated their grade, we want to display it. So we'll use Cout. Cout grade earned is followed by the letter grade, followed by ENDL. So I was hemming and hawing about whether to put braces in there or not. If I wanted to put two lines of code between the if and the else if, I'd have to use braces. You can get away with putting one line of code in without putting braces. But if the code block is more than one line long, you have to put braces. So that's kind of why I was hemming and hawing. In this case, I didn't see a reason to use braces because this is pretty clear. Grade is equal to A. I can't think of anything else I'd want to do if it was greater than 90 except for that.
Could you just repeat what you just said again? I was trying to put braces with Y again.
Sure. Say for some reason I needed two lines of code between the if and the else statement. So say we had some other variable called, I don't know, points. Like you were earning points for a, a degree or something. So then you went in and you said points is equal to 10. And A is worth 10 points, and B is worth a 9 or whatever. So I stuck that there between these two things because I want points set to 10 and I want, grade set to A if it's greater than 90. That broke it. All of this is no longer working. And the reason for that is that you're only allowed one line after an if statement without braces. If you want to put more than one line, you have to put braces. So to get that to work, I would have to do this. And then all of a sudden my errors go away. Does that make sense?
Then if you were to go grade is equal to B, you just have to add more braces.
Exactly. So if I want to do points is equal to 9, again, that breaks everything below it unless I put the braces.
Gotcha. Alright.
Yeah. Okay, now I'm going to delete that stuff. I hope y'all didn't type that. There. Let's test it. I didn't actually test it. The student scored. The student earned a 75. And it closes too fast. Alrighty. Well, the Windows users, there's more than one way actually of doing this. But what I'm going to do in this particular case is just do the call to system pause. That doesn't work for you Macs or Linux users, so you probably just not even need that at all. Into the student score, 75. The grade earned is a C. See if I can get all that on one screen. Probably getting to the point where you can't read it. Okay, so as the next part of this assignment, once everybody gets it done, anybody getting syntax errors? And I know that I type faster than most people, so. An Apple Watch or something, cool. You just need a hand on it. No, I'm kidding. That's awesome. Got yours working? Does it run? Okay, cool. All right, let's take a look. Semicolon here. Just like you can't put one after an if statement, you can't put one there. Very reasonable mistake. Just like you can't put a semicolon after an if, you also can't put one here. If you put one here, this is how the program treats it. So if you put one there, then eventually every grade will be an F. So no semicolons after ifs, no semicolons after elses. You asking a question?
Yeah.
Oh, isn't that weird? What's that doing? A right-hand operand of standard string. Under IOStream, do # include string as well. And that's kind of my fault for not leaving that on the screen long enough, but that also needs to be part of my boilerplate.
I
Yeah.
didn't read that. Okay.
So everybody got it working? Raise your hand if you need help. Don't be shy. Okay. Here's what I want y'all to do next. Modify the program. I'm just going to put this in a multi-line comment. So that it uses the following grading system. 98 greater than or equal to 98 is an A+. Greater than or equal to 92 is an A. Greater than or equal to 90 is an A-. And the same for B and C and D. So greater than or equal to 88 is an A, is a B+. Greater than or equal to 82 is a B. And greater than or equal to 80 is a B-. So you're just going to have to change your if statements. And I'm not going to make that change up here right now, so y'all go ahead and work on that by yourself.
Do we need to put all that in there, greater than or equal to 98 A+, greater than or equal to 80 B-?
Exactly. If the grade is a 98, 99, or 100, you want to print an A+.
Well, I mean, like, do we need to put that comment in there? Or
Oh, you don't need the comment. Just make it do it. Yeah. You don't have to type this comment in unless you want to. Just make it work. You know you have a really mean teacher if he assigns you an F minus. So don't bother doing it with F. Just do it with A, B, C, and D. I see I'm interrupting, I'm sorry, but I see an underlined over here. Oh, that's because there's a parentheses in front of that 92. So at this point, it just becomes a speed typing competition. Cool. Good deal. Type in 61, make it D minus. Cool. Computer's working.
What's that?
Working on it. Yeah. Oh, you typed the comment in. That's cool. Yeah. Something to think about for those of y'all who've already gotten it working is what if we took all the else's out? Would the program still work or not? And the answer is no, but be interesting to see what it does. I'm going to make the changes required up here as well. So when you're looking at something like this, it looks kind of repetitive. And as a programmer, you start thinking things like, wow, that looks repetitive. Is there a simpler way of doing it? A shorter way of doing it? And all I'm coming up with are more complicated ways of doing it rather than shorter ways. So, you know, maybe we'll revisit this program a while later after we've learned something else, but even though it's long, this seems like a good way to do it.
I have a quick question.
Uh-huh.
At the top where it says below score, technically here we don't really have to put equal to 0 at the very top, do we?
No, we don't.
We don't really have to define it as.
You don't have to initialize it with a value.
Okay.
When you're using CIN, there are times when it's easier to debug if it has a value going into it, but I can't put my finger on why. I can't explain it. So, no, it's not necessary. The only thing you might want to do is give them a starting grade of F, and then you wouldn't need that final else. Because, you know, if none of the ifs were true, then it would still be an F. You know, you could come down here and delete that one, but it's not like having those two statements hurt, so. All right, guys, anybody need more time on this? Or are we pretty good? Let's look at the in-class assignment. Not that that wasn't an in-class assignment, but you know what I mean. There's one already waiting for us. Yeah, I'll come look. And I'm sorry, I did move too fast. I apologize for that. Go ahead and read ahead on the file in class G. There is one, isn't there? Yeah. So download the Word doc, open it up, gawk at it. That reminds me, remember that question I asked, would the program work if it was just else's? Excuse me, if it was just ifs rather than else if? And the answer is no. Watch what it would do. Can I just do a search and replace and remove all else's? Maybe I can. Find and replace, quick replace every occurrence of the word else with nothing. Let's see if this will work. Okay. All right. The code kind of looks good. If the score is greater than 98, it's an A+. If the score is greater than 92, it's an A. If the score is greater than 90, it's an A-. Looks good, but if you run it, okay, I'm going to make an A. I typed 78. Oh man, I made an F. Why did that happen? Because without the else's, it executes every single if. And when it gets down here to this last if, well, even if that one was still there. Let's try it again. That was a mistake. You have to have that one, that last else there. Okay, so I made a 98, and it says D-. The reason for that is without the else statements, it's executing every single one of these. So the first thing it does is it sets it to an A+. And then also, 98 is greater than 92, so it sets it to an A. Also, this 98 is greater than 90, so it sets it to an A-, and so on. 98 is greater than a 62, so it sets it to a D. And 98 is greater than a 60, so it sets it to D-. Does that make sense? Hope so. So I broke the code by removing the else's, even though it looked plausible. You have to arrange the logic of your if statements in such a way that if only one of them is supposed to be executed, and in this case this is true, you really only want one letter grade assigned, you're probably going to use else statements to make them, quote, mutually exclusive. You only want one of these options to happen. You don't want it to print both C or C- or something like that. Okay, so on the second page is source code that will calculate the mass of a sphere, determined on its diameter and type of material. The program will ask the user for the diameter of a sphere in feet. Then it will ask for the material, either ice, aluminum, or gold. It determines the density based on the material chosen. So if it's ice, it's got a density of 55 pounds per square foot. Ice is a lot lighter than aluminum, which weighs 165 pounds per cubic foot. Aluminum's a lot lighter than gold, which weighs, 1,200 pounds per square cubic foot. So if you threw a block of ice at somebody, they could probably carry it around. It's 55 pounds. If you threw a cube of gold at somebody that was a foot per side, it would do serious damage to them. What in the world are we talking about arrays of bytes for? I don't even know what this C means here. If you're looking at the program and it's in edit mode, delete part C. Okay. So you could type this code all in, or you can just copy and paste it. In this case, since it's about, 30 lines of code, I just recommend copying and pasting it. So this is going to turn into homework. So go ahead and do File, New, Project, and make a new project. And then just plan on extending it when you get home, the way that the instructions ask you to. So I'm going to call this sphere, but I'm going to put my initials in front of it. JGT sphere is the project name. I'm going to add a new source file to it. Add new item. I'm going to make the source called JGT sphere source, my initials. And I'm going to add the good old boilerplate to it. No, I'm not. I'm going to copy and paste it out of the program here. This one doesn't include # include string, but it never hurts to # include it. So underneath IOStream, if you want to do # include string, nothing wrong with that. Once you've cut and pasted it, scroll up and down the code actually trying to follow the logic of it. Think, if I had to flowchart this, kind of what is it going to look like? What's the first thing the program does? What's the second thing that it does? What's the third and the fourth? And then go ahead and run it. By the way, a double is just an extra precise version of float. I think we already talked about that. A double holds a much larger maximum value or a much more precise, smaller value than a float. Did we have to make these doubles rather than floats? No, because we're probably not dealing in numbers larger than 9 gazillion or whatever the maximum float is. The meat of the program is right here. Well, let's look at it. What does it do? It asks for the diameter and it stores that in a variable called radius. But what is radius really equal to? It's diameter divided by 2. So it converts it to 2 by dividing by 2. Look at this divide, this slash equals. That's something that we hadn't quite done yet. But it takes the number stored in radius, divides it by 2, and puts that result back into radius. That's what slash equals does. And there's also plus equals, a minus equals, and times equals. So if it said plus equals 1, that means add 1 to it and store it back into it. So then it asks for the type of material. 1 for ice, 2 for aluminum, 3 for gold. And that is used down here in this series of if, else, if statements. If they typed in 1, the density of ice is that value. And if they type in 2, the density of aluminum is that value. Else, if they type in 3, the density of that is that value. And then there's an equation down here for calculating the volume of the sphere based on the radius. And you just have to kind of trust that that equation is right. The volume of a sphere is 4 divided by 3 times pi r cubed. And that's what this is doing. It's using a function called POW to raise radius to the 3rd power. And I do have a question for y'all, is look at this line right here and tell me why it says 4.0 divided by 3.0 instead of just saying 4 divided by 3. Based on what we were talking about earlier in class today.
Is this a remaining thing?
Yeah, those are ints. And so what's 4 integer divided by 3 integer? 1. So yeah, that'd be useless. Take all that information and multiply it by 1. So at least one of these has to be a float in order to get it to do the correct math and make it equal to 1.333. Alrighty, I'm going to test this, see if it works.
Might need a system pause.
Oh yeah, thank you. Do above the return 0, put a system pause. Okay, I have a sphere that's 10 feet wide. It's made out of gold. And hoo boy, weighs 620,000 pounds. Awesome. Alrighty. So, the homework portion of this, I mean, that was pretty easy, huh? Because all we did is cut and paste. The homework is to take the extra information, I'll be right back there, and make it also support marble and golf ball material. Well, that one's kind of stupid. Oh, that's not right.
No, that's the right one.
Is that part C?
That's
Did I take out the one?
okay. The programming assignment's actually on the last page. Sorry. Thanks. So, add to it, as well as ice and aluminum and gold, there are some other materials here. There's iron, there's cedar, there's soil, there's paper, and there's another thing that's even heavier than gold called osmium. So the density of water must be about 50 pounds per cubic foot. And anything that has a lower density than water will float. So there's only two things on here that would float. No, it must be a little bit greater than 55 because ice floats. But anyway, cedar, a type of wood, definitely floats because it's less than the density of water. And so is paper. Paper floats. That will be the homework assignment. Add the option to choose from any one of those extra materials and calculate it. Oh, were you asking me a question or were you going to tell me what? I'm sorry. You didn't want me over here. Oh, I feel so left out.
So are we doing the in-class, just copy and pasting this? Is that-
Yeah, the in-class part was to copy and paste and upload into the Dropbox, but we're going to make a homework box for doing this one.
But you said you wanted to loop.
Yeah. I did. You read this stuff so much better than I do. Here we go.
I never
This is
forgot
right
to
next to
loop, and I forgot because I kept getting errors.
If you can, make the program loop over and over until the user enters a negative value. I'm going to show you all how you could make the program loop. You don't have to do this, but where it says enter the diameter of the sphere in feet, put parentheses or 0 to quit. And we haven't talked about looping yet, so I was kind of getting out of turn by asking you to do this. Now to make it loop, I'm going to use what's known as an infinite loop, a while true. So up at the top of the program, I could even put it above this double X, Y, and all that stuff. Right up here, at the very top of the program, put while true, and then put a brace after it. And just space it over like 2. And then go down to the bottom and put a closing brace right above the system pause. And after you put that closing brace above system pause, come back up here under the line that says radius divide equals 2 and make it say if radius is equal to 0, break. What that does is it breaks it out of the infinite loop if they type in a 0. Now, like I said, I don't really care if your final result does this or not. But it's good for you to see this now because later on you'll see it again. So I had to put this up at the top of the program above the variable declarations, that while true there. And since I have an opening brace, every opening brace requires a closing brace. So I had to scroll down here above my system pause and put a close brace. And check it out, it reformatted it for me. That was real nice. And then I scrolled back up and under the line that said radius divide equals 2, I added this statement, if radius is equal to 0, break. That gets it out of the infinite loop, but if they type in anything else other than 0, it goes ahead and runs it. And the loop means that it'll keep doing this over and over until you finally do type in 0, or you close the window. Let's see if that works. Enter the diameter of the sphere in feet. It's a 10-foot sphere. It's made out of ice. Weighs 28,000 pounds. Enter the diameter of the sphere in feet. What were some of those other values, like a golf ball? What would a golf ball made of gold weigh? Let's go up here. The size of a golf ball is 0.14 feet, so 0.14. It's made out of gold. Yeah, it weighs almost 2 pounds. All right, and then I'm tired of playing with this, so I'm going to type in 0 to quit, and it's done. The program's done. That's how you make a program loop. Is you put a while up at the top, and it can get a little bit more sophisticated than this, but this is essentially it. This is one of the simplest ways of making a program loop. Alrighty, let me make a Dropbox for this version of it so that you can zip it up. So there already is a Dropbox for that, but we need one for the homework as well. While I'm thinking about it, when I had us delete that part of the in-class assignment, I should go ahead and delete that. Upload the modified version. Go on to the next chapter. I don't want to stupefy y'all by going too far, but we have to make the best use of our time. So we're going to skip to chapter 3. And this stuff's looking familiar. Have we already done this? No. Just talking about stuff that we have done before, right? But we haven't actually lectured over this. All right, expressions and interactivity. The CIN object, we've been using it already. What does it do? It reads input from the keyboard. It's called a stream. There are other kinds of streams. You can read from the internet. You can read from a file. And the syntax is exactly the same. You just use the arrow in order to read from the file or to read from the internet. And then input is stored in a variable. And you can actually store more than one bit of information. Like if you wanted to allow them to type in a first name and a last name, you could do this. Don't add this to your program, but you could do this. String, first name, comma, last name. And then you could do cout, enter first name and last name, separated by a space. I'm going to leave that off. And then you could do cin into fname, and then into lname. And that would let them type in two things. The first thing they typed in would go into that one. The second thing they typed in would go into that one. Now, to be honest, I don't do it that way very often. I think that makes it a little harder to read, but it's not that much harder to read. So if you absolutely know they're going to be typing in two things at once, you know, separated by a space, that'd be a good way to do it. And we already know how to use this, so I'm not going to sit here and dwell on the slides too much. So the cool thing about CIN, and CIN, this syntax, arrow, arrow, is pretty much unique to the C++ language. You won't see that in C# or Java or JavaScript or other things like that. But that's okay. You'll learn the other way of doing it, you know, once you learn those languages. It's just kind of a unique way of doing it. CIN is special because it will convert whatever you type in into the data type here. So if height is an integer, the string that they type in is converted into an int. If height is a float, then the string that they type in is converted to a float, and so on. A prompt is a message that instructs the user to enter data. You should always display the prompt before you ask them to type in something, because otherwise they won't know what they're supposed to type. You can use CIN. Are there any questions so far? We are still awake. Attention is wandering. Sorry. Can be used to input more than one value, in which case you just put more than one variable. If you wanted to let them type in 3 variables at a time, you type CIN, arrow, arrow, first variable, arrow, arrow, second variable, arrow, arrow, third variable. If you do that, the user has to separate the data that they enter by spaces. And the order is important. The first thing they type goes into that first one. The second thing they type goes into that second one, and so on. All right, mathematical expressions. Kind of already talked about mathematical expressions, I believe. A mathematical expression is a series of one or more symbols, including variables, literals, which are the numbers, and the operators, like plus signs and minus signs and stuff like that. So it could just be one thing. This is an expression. If I do this, x is equal to 1, that is an expression. It's a pretty dang simple expression. But if I do this, x is equal to 1 plus 2, that's a little bit more of a complicated of an expression. If I do x is equal to x times 2 minus x divided by 3, that's also an expression. It's more complicated still. So the expression can consist of variables, it can consist of literals, it can consist of operators, and it can consist of function return values, like that POW. That POW function is a math function that raises one number to the power of another one. So if I do x is equal to x, POW x comma 3, that raises x to the power of 3, which is x times x times x. So this is an expression. It's also a function call. So you can create complex expressions, whoopsie, by using multiple mathematical operators. An expression can be a literal, variables, or mathematical combinations of constants and variables. You can assign them to another variable, or you can pop them out to output with cout. The order is important. Here they're talking about an operator that we don't really think of as being operator. The minus sign has two meanings, doesn't it? If you type in minus x is equal to minus 10, that means x is equal to negative 10. They're calling it the negation operator. That happens first even before parentheses and multiplication and stuff like that. But I'm going to kind of skip that when I say PEMDAS. And then so multiplication and division happen next, and then addition and subtraction happen after that. Modulus counts as a kind of division. So when you're thinking PEMDAS, modulus is up there with multiplication and division. So here's this expression. What happens first? The multiplication. Once a multiplication has happened, everything happens left to right. So that would happen next, and then lastly we would subtract 2 from it. So what's 2 times 2? That's 4. And then 2 gets added to that, 2 plus 4 is 6, and we subtract 2 again from it, and that goes back down to 4. So the order of operations, well, unfortunately the answers are right there, but if I stretch this out to the point where we can't see the answers and zoom in, we can figure them out. What happens here first? What's the first operation that happens in that line?
8 times 4.
Yeah, so that's 8 plus 5 is 13. What about this line? What's the first thing that happens?
5 minus 3.
Yeah, the division, so that's 5 minus 3. It's 2. What about here? We know that multiplication happens first, so that's 24. 8 plus 24 is 32, minus 4. It's 28. Let's see if we got them right so far. Of course we have them right. Yeah. And what's 17 modulus 2? Well, 2 goes into 17 8 times with how many left over? I heard one person say it. I want to hear 2 people say it. 1. Yeah, okay. So this is 4 plus 1, which is 5, minus 1, so it goes back to 4. And here we have one multiplication that happens first, so it's 6 minus, well that happened first, 6, that's 0, plus 7, minus 1, so we get 6 again. You can use parentheses to override the order of operations. Here's the same series of numbers and symbols, but using parentheses in order to change the order in which they happen. 2 plus 2 is what? No, this happens first. So that is 4. So 2 plus 4 is 6. Minus 2 is back down to 4. But here we have to do what's inside the parentheses first. So that's 4. And then we do the multiplication. 4 times 2 is 8. Minus 2 is back down to 6. So what do we do first here in this one, on this third line? Yeah, we do the parentheses we do the parentheses first. So 2 minus 2 is 0. And then we do the multiplication first. So 2 times 0 is 0. And then 2 plus 0 is equal to 2. And then lastly, we have 2 sets of parentheses, so we'll do them left to right. We do that one first. What's 2 plus 2? That's 4. We do that one first. What's 2 minus 2? 0. So we have 4 and 0, and then they get multiplied together to make 0. Okay, so I want y'all to practice this a little bit. So I'm going to type a few expressions up here. Just open Word or Notepad or whatever and write down the answers. X is equal to 2. All right, that's enough. Those-
X, Y, Z name.
Yeah. Just tell me what X, Y, and Z and A are. don't see a lot of typing. I'm gonna expect that people are done. What's this first one? What's A? Yeah. What's B? Yeah. What about C? Not sure I heard everybody resoundingly answer that one. What was C? Yeah. And lastly, yep. Good deal. Y'all have aces. I didn't throw modulus in. We got to have a modulus. Okay, B is equal to 2 plus 2 modulus 3. So just as a reminder, what's 2 modulus 3?
2.
It's actually 2, because 3 goes into 2 0 times with 2 left over. I totally messed these letters up. X, Y, Z, A, and B. So that's 4. All right. When you're taking the exam, there'll be, like 5 questions like that.
When is our exam?
Good question. We need to pick a date for that. Pick a date, any date. We started that, let's call it a midterm. Let's,
Do next Wednesday?
I would make it,
Or 29th?
yeah, let's do 29. That's cool. Did I hear a no? A wail of terror? We can make it the 6th, July 6th. We will have had 4 weeks of class by then. July 4th is a holiday, so you'll be well rested or sore or drunk or something, I don't know. Anyways, alrighty. We'll take a show of hands. Who'd rather have it on the 29th and who'd rather have it on the 6th? 29th.
Either way is fine.
There were way more hands for 29.
Is that
Sorry, guys. If you can't take it on the 29th, talk to me and I'll make other arrangements, okay? So we're all cool with that? Okay. Let's make a note of that. The exams are open book and they're also open PowerPoint. You can open anything that's uploaded into our D2L section. So don't stress about them too much. I did tell you that the last class in which I gave an exam, 98% of the people made a 98 or above. It was ridiculous. I did too good of a review. So I'm going to make this one a killer exam to make up. No, I'm totally kidding. I'm totally kidding. But it's not going to be a grueling exam. Almost everybody's either going to make an A or a B. In fact, I want everybody in here to make an A or a B. And if you don't make an A or a B, I'll probably give you extra credit homework so you can get it up there, because I want y'all to be relaxed about taking the exam. The point of the exam is not just a test to make sure you've learned something, but it's also a learning process. After you've taken the exam and you've done the review and and you see what you did wrong, you've learned more than you did before you took it.
Are you gonna tell us what's over on that Monday?
Right. We'll do a review on Monday. So midterm exam, the midterm will be June 29. I know what some of y'all are thinking. Somebody's thinking, I'm going to take July 6th off so I can have an entire week off. I shouldn't have said that because now somebody else is thinking that who wouldn't have thought of it first. Don't do that. Come on, come to class. Okay, and by the way, no class on Wednesday, June 20. June 22, excuse me. June 20 is today, so if there was no class today, then what are we doing here? So I'll send a text out, but just as a reminder, there will be a link to a video and a little worksheet to work on, so that it's not completely wasted time. I think we've done about enough for today. Will anybody complain if we get out 20 minutes early? Okay.